Hello and welcome everybody. I'm Andrea Goldsmith, Dean of the School of Engineering and Applied Science at Princeton. And I'm truly delighted to welcome you to this conversation with two amazing people, as you'll see throughout the conversation. Today, we'll hear about a topic that is not just important to me as Dean, part of my strategic vision for engineering, but it's important for anyone interested in entrepreneurship and in how data and machine learning are driving the growth of some of the biggest and most influential companies around the world. Indeed, machine learning is encompassing so many topics and so many business models and so many products. It's a really exciting time in this space. So the first person I want to introduce is Patrick Wendell, and his story is truly inspiring. He majored in computer science here at Princeton, graduating in 2011, and then went on to pursue his PhD at UC Berkeley. Go Bears! I also got my PhD from Berkeley, but he went a slightly different path, which just shows that the best laid plans can sometimes get derailed by other exciting things. He quickly, in his PhD studies, became an early contributor to the Apache Spark project, which is a powerful open source data analytics tool. And before he could complete his PhD, he joined others on the team to found Databricks. Through the team's hard work and grit and resilience and creativity, Databricks has taken off like a rocket because many of the biggest companies and organizations around the world have come to rely on Databricks to harness their data. And this includes a very wide swath of companies, healthcare giants like Merck and GlaxoSmithKline, large tech companies, household names like Cisco and HP, financial services companies like Deloitte and HSBC, as well as government agencies, FDA, NASA, the Army, and the Air Force. So this really shows the importance of managing data and using machine learning in data across so many different areas of technology and the government and academia. So Databricks is clearly making a positive difference for these companies and a huge impact in general on how our data is handled and used in terms of these products and services. So Patrick will be talking with my rock star chair of computer science, Jen Rexford. She also graduated from Princeton. She's a leader in computer networking and has been instrumental in the growth and strength of computer science here at Princeton. I consider her an incredible partner in executing the vision that I have for Princeton engineering. I could really go on and on and on and on about the excitement and influence and impact around Princeton computer science that has really blossomed under Jen's leadership. But for our purposes today, I'll just say that Patrick exemplifies the potential that Princeton teaching and research has to create new pathways, new companies, new endeavors, new ways to use computer science, not just for individual students, but for whole sectors and for society, which is in keeping with Princeton's informal motto to benefit all humanity through the work that we do. As a two-time founder myself, I love to hear of people translating their knowledge and insights from their academic work into ventures that make a positive difference and create companies that change the world. So I'm really delighted that Patrick could join us to share his story, and I hope you'll enjoy the conversation between Patrick and Jen. And please do jump in with your questions at any time using the Q&A button. Enjoy the conversation.
Awesome. Thanks so much.
Thanks, Andrea. So I think just to get us rolling, Patrick, I'd love to have you tell us a little bit about your journey from graduating from Princeton in 2011 to the founding of Databricks. How did that happen, and what were some of the twists and turns on the journey?
Yeah, sure. I'm happy to talk about that. And by the way, thanks for everyone who showed up today. It's great to see all of you virtually, and for everyone who's watching online or in the future, glad you could get a piece of it too. So yeah, by the way, one thing that was not mentioned is Jen was actually my freshman advisor at Princeton, and someone I worked very closely with over the years. And Jen, I went and dug up, I found a bunch of emails you sent me freshman year about, my course selection, and I got kind of a bad grade in one class, and somehow you were all over it and you said, hey, don't worry, it's recoverable. You can get through it.
I think you've done good after all.
Yeah, so it was recoverable, it turned out. But yeah, so I was an undergrad at Princeton. I grew up in San Francisco, where I am now, but went to Princeton, studied computer science and engineering. And actually at Princeton, I got pretty involved in the research side of computer science in the computer systems area. And in that capacity, I worked with Jen and worked with Mike Friedman, another professor, and a handful of other students, and got pretty interested in computer science research. And so I did after Princeton choose to pursue a PhD. And that was kind of a career choice where I looked around at the people I admired, the people I worked with. You know, they were all these faculty members, they had done research at a high level. And I was thinking, oh, wow, I think this is pretty interesting. I might want to pursue this for the next stage of my career. So I applied around and ended up at UC Berkeley. And as I was introduced, I think she said I pursued a PhD. I pursued but did not complete. So I do want to be clear, I don't have a PhD, but I actually went there because there was a group of people who were doing research I thought was really interesting. And what they were looking at was the explosion of data and a few trends that had happened sort of globally. One was that the cost of storing data went way down. So basically, the way that companies and researchers thought about how expensive is it for me to store 1 megabyte of data, it went down by like 10x or 100x over a 10-year period. And that was a result of software and hardware innovation. There was kind of cheaper and cheaper storage devices, and also hardware that could kind of stripe storage across many, software that could stripe storage across many, cheap machines and have it, you kind of see it as almost one big massive storage pile. And so it's just a kind of interesting price-based change where suddenly it was cheap to store things. And so companies just started storing more and more and more data. And at the same time, there was like a few companies that were actually taking this huge data sets and really getting a lot of value out of them. And this was like 2000. So I graduated 2011. So this was like 2011, 12. And the research group was focused on basically how are those companies succeeding that are getting value from these huge data sets? And it was a pretty small number of companies. There was like Google and at the time Facebook, and a lot of what they were doing was using really large data sets to actually optimize ad spend. So they were trying to get you to click on something. And it turned out that if they used inference and machine learning with that data, they could get you to click on things much more than you might otherwise. And that actually made them tons and tons of money. It really was a very high revenue, high margin business. But the way they did that was that they built huge teams of engineers from top schools, including Princeton, and built lots of custom data infrastructure for those companies. So they basically built tools for exploring data at huge scale, for building basic models, for setting up transformation pipelines that move the data from one format to another, for dashboarding, for all these parts of all these things you need to do if you want to really take advantage of large scale data. And that was awesome if you're Google. But if you're like any other company and you can't afford to have huge numbers of engineers that are really expensive, build lots of custom infrastructure, you're kind of toast. And actually we saw that even in the research area, companies were stockpiling data. The cost to store it was cheap. They had kind of aspirations about getting value out of it and being the next Google for their area where they were applying machine learning and so forth. But the actual infrastructure, the technology infrastructure was really behind for doing that, for doing it in a way that didn't require 100 systems PhDs from great schools. So that was actually the research vision that this group was focused on, is kind of how to make it easier, how to make it more accessible to manage data at really large scale. And before I had come, they were focused on, I would say, the lower level kind of compute management layer. They were doing a lot of research on cluster computing infrastructure, and they had this thing called Mesos, which there's a thing now at Google called Kubernetes that's kind of similar, but that was 10 years ago, the Berkeley stuff. And I thought this was just a cool area and a really interesting area. And I went and joined up with some other students and faculty there, and we actually started building this thing called Spark. And Spark was a software artifact we built, which was open source, so we gave it away totally for free. And we were trying to solve the problem of I want to write some simple code that can process a really large data set. So I'm trying to do a prediction. I'm trying to predict, let's say I'm a company, I want to predict which customers are going to churn. I have customers and I don't want to lose them, and I'm building a web service, and I have all these inputs about how often they're using the product, and how many support tickets they've filed, and and how many distinct users they have inside of their company, but I want to predict, am I going to lose this customer or am I going to keep this customer? It turns out that that's like a big machine learning data modeling problem. And what was happening is that companies had problems like that. They had big, messy data sets, but they had trouble. There was no real like framework where they could just write some declarative logic, like, hey, take the data, drop these columns, do this machine learning algorithm on it and pop out the answer. It was actually really hard to do that once the data scale got large. If it was a small data set, it was easy. You could just like use Excel or just use, write a little code in Python or something. But the data set was huge. It was really, really hard. And so that was the problem we were solving with Spark. And it turns out this thing, Spark, which was just basically a way to write some code, and Spark would deal with all the hard parts for you. So we would deal with distributing the data around maybe a large cluster. We would deal with if there was machines that failed during the execution of your query, because if you're running on 1,000 machines, the odds that one of them is going to fail is actually kind of high. We would deal with scheduling the work and where everything goes, and just give you a very simple interface to sort of express the thing you were trying to do and kind of have the infrastructure get out of your way. And that thing, Spark, became very popular. It actually was, even just as a free thing we were doing at, I was at Berkeley, so we're all about free and open and like community powered. And so we gave that totally away for free. It was actually powering our research. It was not a company at all at this point. And that thing became really, really popular. So we left. So at some point, like I was getting phone calls from businesses that were like, hey, how much do you charge to support like Spark? And I was like, hey, I'm just trying to get like my dissertation, and I don't even know if I'm going to be a good PhD student. And they were calling and asking about, like, they thought we were a company, because like they were like, I don't understand who else would have put out this high quality of software. And they were like asking, do we charge by machine or do we charge by, and I was like, I don't charge anything. This is like open source software. Please stop calling me. But at some point we were like, oh, you know what? The fact that so many people are taking this thing we built, which was largely a volunteer thing made by PhD students at Berkeley, and they're using it and they're getting a lot of value out of it, that must mean there's like a real need here. Like this problem that we stumbled on as a research problem, turns out it's like a very present day problem for a lot of companies. So at some point, I think I was, a few of us, I was one of the first, we're kind of like, oh, you know what? Maybe it would be interesting to start a business around this to keep supporting not just Spark, but kind of, I would say, this general area of interest where we had, which was like empowering companies to get more from their data. And we left in 2013. Me and another student kind of started it, but we were like, we actually like wanted more help, because I think my lifetime career experience was that 1.5 years in grad school. So I felt like, okay, maybe we need more help than just, me. And there's another student so we actually recruited a larger founding team in the early days, and it ended up being 6 of us that left Berkeley, which is kind of a big founding team, but it was a few faculty and a few students, grad students. And we left to start this company, Databricks, with the idea that, we were going to use this Spark thing that we were working on as a starting point, but we had a much bigger vision for building tools and platforms that could let kind of every company in the world that wants to use data and machine learning to, empower and inform their business. And the applications of this are very broad. So I gave, customer churn as an example, but there's many others. I mean, our biggest customers these days are everything from pharmaceutical companies that, they're trying to discover drugs using data modeling, because a lot of the frontier in drug discovery is largely, genetic, thinking about drugs that target certain regions of your genes. And a lot of that turns into like big stochastic math problems that are running on huge data sets with very long gene sequences and hundreds of millions of sequenced genomes. And it turns out it's just a big, messy data inference problem at scale. That's like just one of 10 or 20 different types of industries that have similar problems. And it's turned out over the years that we've been able to build sort of repeatable, highly leveraged software that can let all those different businesses take advantage of the work we're doing. And I guess I'll pause there because I've been talking for a long time. So that kind of got us up to like why we started it, and then a very fast forward to what it looks like today. Obviously, there was 8 years in the middle of building a company. What would be most helpful for me to talk about next?
I mean, I'd be curious. I mean, first of all, I'm fascinated by the diversity of customers. I'm curious if you have experiences from particular customer sectors that are not tech heavy, where we might not think they need to use data, but they have tremendous need. And what is it that, what are they trying to do?
Yeah, it's interesting. And actually, I would say that most of the opportunity is to bring machine learning to companies that are not tech heavy. If a company's already, there's kind of like 10% of the global economy, 5% that are really tech forward. They have tons of software engineers. They've already been kind of doing machine learning, like the Googles of the world. And, it's hard for us to provide them a lot of value because they already have thousands, tens of thousands of engineers who are just doing nothing but focusing very specifically on like how to make you click on those ads, basically. Or in Facebook's case, they are trying to make sure that you don't ever leave Facebook. They want to keep your attention on their site. It turns out where the opportunity is right now, the frontier is actually, it's kind of like more going 0 to 1. It's where there's huge swaths of the global economy that have never put machine learning or data science into practice ever. And the gains there are huge because they're just starting to use inference in a way that they never did before. And it's very low hanging fruit in many cases. Whereas, trying to optimize some model that's been optimized for the last 10 years is very hard. So a good example is like John Deere is a huge customer of ours. Okay, John Deere, I believe they're the oldest company in the United States, or they're one of the oldest companies. So this is an old school company that largely makes tractors. And so why do they need machine learning? Well, it turns out that they have many, many use cases. Like there are sensor devices in a lot of the things that they sell now. They're constantly emitting data, and they can do everything from like predictive maintenance. Like, oh, by the way, this thing is going to fail soon. Just, you give a phone call to the customer that they need to go in for servicing. But also like they have crazy vantage points of like, global agricultural patterns and, where are there droughts, and because they can look at where machines are being used across the entire globe. And that can help them, not only provide this data to researchers, but it can also help them understand where their supply chain needs to focus and where they can forecast their demand and so forth. So a lot of I often call it like unsexy machine learning. A lot of the things that we do are taking industries you might not have thought of as extremely tech forward and helping them become tech companies. And there's this guy, Mark Andreessen, who's actually one of our investors. He has this famous quote that like software is eating the world. But by that, he means every company is going to become a software company eventually, or the ones that don't are going to lose out to the ones that do in the market. And I believe that is true. And also, if you look within software, data and machine learning are often a huge fraction of what the overall software spend is at a company. To some extent, they need to get everyone laptops and they have their kind of corporate IT spend, but they spend a lot of money on just deploying the data they have, which in many cases they consider a proprietary asset. So I think we're fortunate to be in a position of selling those tools in a time when many companies are trying to become very data centric and consider their data as a strategic weapon. In that war, so to speak, like we're sort of selling the weapons.
So I'm curious, I mean, you must at Databricks have a lot of people that are ML experts and people that are, systems, have a strong systems background. I'm curious the balance there. And also in general, I mean, ML is a super fast moving area. So I'm just curious to what extent that fast moving set of techniques is something you guys have to really hustle to stay on top of.
Yeah, it's a great question. And I would say that people often think that Databricks is a lot of mathematicians running around and building faster machine learning models. But the truth is that most of the work we're doing are like the boring parts. And it's actually all the infrastructure around machine learning. It's things like, how do you set up your security model for your massive data sets? We have customers that have compliance issues. They have personal health information. They have credit card numbers. They need to, and suddenly they have petabytes of these things, and they need to figure out how to sort of architect their data catalog in a way that allows access to data very broadly in the company, but is also secure. We deal with just managing the data at scale, having to meet SLAs with your data ingestion, having to we also do a lot of work, and I would say like the user interfaces for interacting with large scale data sets. Like, how does a team get together and build machine learning models and deploy them? We actually do very little work on like the core models and model the actual like mathematical computing part of machine learning. And the main reason is that there's a lot of work being done on that, and it's largely being released free and open by the people that are working on it. There's tons of people at the big tech companies that are working on it. There's tons of people in sort of academia that are working on it, and it's become a culture where you give away the most interesting and coolest model building, your model implementations, and other people use them, and that's awesome for our customers. It means that itself is not a great business, because if the market price is zero, it's hard to make a lot of money. So we're actually doing everything around that. And we largely partner with the companies and the institutions and researchers that are building the models. And we kind of do everything else. Again, it's kind of the unsexy part on purpose.
Cool. So there's a question in the Q&A about the origination of the idea behind the business. And you spoke to this a little bit in terms of recognizing that Spark was something that people needed supported. So I'm curious, both how did you come to think about Spark in the first place, but also how did you figure out what support means, if that makes sense, right? I mean, it's kind of an abstract concept. What is it that people really need help with?
Yeah, definitely. So so first of all, Spark was open source. And when we built Spark, it was actually just a happy coincidence. And it even started before I got to Berkeley. There was a group that was competing. Netflix did this big competition. This is kind of a crazy story, but they called it the Netflix Prize. It was in like 2010 or something. And they were trying to improve their recommendation algorithm. So like when I and this was, I think, still when Netflix was doing like emailing you DVDs. But so they would know that, hey, I've emailed Jen Rexford, these 4 DVDs, and which DVD should I recommend her next? And if they solve that problem well, it's hugely important for their business, because their whole business is keep people on the Netflix subscription. And it largely still is, even though that it's digital. It's the same model, basically. And they released a sort of anonymized data set where, the names of all the things were anonymous and the names of the people were anonymous, of like who all has watched what movies. And they wanted the public to come back and find out the best way to predict based on someone's prior history of renting movies, what movie should we recommend that they'll watch next? What will keep them engaged with Netflix? And they called that like the Netflix Prize or the Netflix Jump. And it was $1 million to the team that got the sort of optimal algorithm. And there was a team at Berkeley that was competing on that. This was actually not the research group I joined. There was like the next door group or something. And in fact, I think there was this guy, Lester Mackey, who was doing it, who I think actually might have even been a Princeton alum.
Yep.
I didn't even
he's a little bit of our department also.
Yeah. So Lester was doing that. And I think he was sitting next to Matei, who's the guy who built Spark. And he was super annoyed because he was trying to use this like older generation of tools to kind of, it's basically a big data problem. You have tons of data sets, but you also have some machine learning in there to kind of figure out. And then you're trying to decide, do I try to like sort of improve how I'm enriching and featureizing the data, or do I try to make the algorithm better? And there's like different ways to, and he was so angry because he was using this previous generation of tools. And he was like, I think it was some version of like, hey, Matei, do you think you can do better than this? Because like, this is just too slow and it's not able to scale between his productivity as a user and the actual like core implementation. It was just too slow. And I believe that was like the seed of Matei. Matei was like, oh, I think I can do better than this. And Matei became a co-founder of mine. And he had started Spark really to solve that narrow problem of just like, this particular data machine learning problem is too slow, and I need a way to go faster. By the way, I think they came in like second or third. They didn't get, and I think there was like no prize other than first. So I wish I could tell you that they won, but I don't think they won. But they got pretty close. And I think the winner was like 100-person research lab that was like only focused on this. And, this was like poor Lester just doing this like in his spare time. So I believe it was Spark itself was started with that product market fit of one guy. Like it was product market fit for Lester. But it turned out that like there was actually pretty quickly, many other companies, even in those early days, that had this problem. And when we started the company, the hard part was that Spark itself was free. This was like the Berkeley, hey, we're giving this away. It's like it was under the most liberal license possibly. Like not only could you use it for free, if you're a competitor, you could take it and you could try to sell something on top of it for free, which I do actually think is a good license in a lot of ways. But that meant that, we were starting a company. A company needs to have revenue and it needs to have earnings, and it can't like just take in, expenses and give out something that's free. So we had to decide what to do. And I actually used the word support earlier, but we decided not to do the earlier generation of those businesses had tried to do something where you had the free thing out there, and then you offered like, oh, you can call us whenever you have a problem and we'll fix it for you. And their main business was selling the time of those human beings that are doing support. And that's that you can make money from that for sure. But that type of business is not a very scalable business. You want to sell 10 times more support, you have to hire 10 times more people. And you can get some efficiency out of it, but it's largely just a margin on a human being's time. What we decided to do was build actually proprietary software sort of around and enhancing Spark, and built actually a lot of other things, some of which have nothing to do with the Spark, that sort of part of the execution. It's like about a UI for doing data science, or it's about cluster management tools or something like that. And we made many of those things proprietary, and we sold them as a software as a service offering. So you really only interacted with them via APIs, basically. And that was a much more scalable business, because if we want to add 10 or 100 more customers or 1,000 more, we don't have to scale our costs proportionally. There's a lot of like leverage in the way that we can deliver that, and therefore the margin is really good. So we decided to build that kind of business very early, and it was actually one of the most important decisions in the company. But that still leaves the question, okay, well, what exactly do we build? Do we build like a UI for doing data science? Do we build tools for the administrative person who's trying to control the costs? And we actually that was a very difficult decision. We actually pivoted a little bit within the different options in the first few years of the company. But the way we decided was we went and we spent a lot of time of people using this stuff, especially in very tech forward companies where they were kind of willing to talk to a tiny startup. Because if we at that stage went to, who was I talking about? John Deere. If we had gone to John Deere when we had, 10 employees and we had an idea and the stuff didn't really work, they would have been like, no way I'm taking a risk on you. So you need to start with a different cohort of customers and try and get the right product for them that you think will translate relatively well to the more mature part of the market as well. Does that make sense?
Yeah, that's really interesting. I mean, I was going to ask you, maybe I still will, like what surprised you along the way? And I think what you just said a moment ago, maybe a piece of it, right? In terms of, there seems like there was both some pivoting at the beginning and this sort of getting the bigger customers after the medium size and after the small, but it's tricky, right? I mean, the customers that are too big don't need you, and the customers that are too small maybe aren't able to take risk.
Yeah, it's really hard for that reason. By the way, that's why in enterprise infrastructure, it's very hard to start a company. Honestly, some set of coin flips went our way. I mean, we definitely, I think we did a good job. We hustled, we tried to do everything right, but there's a lot of just luck that you need to have on your side of getting those first few customers that are happy with your product, that you can parlay into a little bit more funding, that you can parlay into more marketing to get the next set of customers. And it's very hard to do this. And if you look at how many large enterprise technology companies have been created that are, tens of billions or $100 billion company. We're not there yet, but hopefully we will be. It's like once every 10 years. You got VMware, and then you got one every 10 years that becomes this really big scale of company, because it's just a hard market to get into. And a lot of things need to go right for you to get from that early stage to the stage where we're at now.
Yeah, and you're obviously over a certain hump right now with the company valued at tens of billions of dollars already. And I'm curious, as you've moved to that scale now, what are some of the new challenges that you face? I mean, obviously the size of the company has grown a lot, so the culture must be, especially with the last 2 years, must be challenging. But I'm curious in general, as you try going forward, what are some of the newer challenges you're grappling with?
Yeah, it's definitely really different at every stage. So at that beginning stage, as I said, it was a lot about just finding product market fit. Can we build something that people want? And at some point it transitions to okay, how can we scale this thing? And there's kind of two dimensions to scaling. One is even just taking the current thing you have, let's say you didn't even change the product at all, but suddenly you need to accommodate 10 or 100 times more customers. That's actually really hard. You need to scale the engineering teams, you need to scale the product, you have to rewrite a lot of the code, you need to scale the way your sales works, you need to scale the way your support works. You need to basically make this thing a lot bigger and hopefully make it more efficient along the way, because you do a lot of things at the beginning that are inefficient, which is okay, but at some point you're a mature company, you need to do it efficiently. The other thing is how you continue to innovate, because the trap a lot of companies get into is they have one good idea, they kind of try to grow that thing, and they're not ever really able to come up with a second act. And there's like, even the public markets are like littered with companies like this. Like they had like one good idea, they got to like be, a few $billion company, and they even got like 100 million or a few $100 million in revenue. And they got that thing to be pretty efficient, but the growth is like, they're not growing because they, when you, in some sense, these two things contradict each other. Like getting really good at just predictably delivering the thing you already have is like a totally different skill set than building a new thing that's probably high risk. You don't know if it's going to work. You might need to invest a lot ahead of the revenue. It's not as efficiency oriented at the beginning. So I think the companies that become these like iconic, huge companies, if you look at like Amazon Web Services, it's just part of Amazon, but it's really a separate business. Like what they did well is that they had one thing, which was these VMs. Actually, they had VMs and storage at the beginning. And they not only made those bigger and better and faster and more scalable and turned that into a many billions of dollars revenue business, they also like invented a bunch of other stuff along the way. So I think for us, like there's kind of two challenges we're doing at the same time. One is just like scaling the thing that's there now. And that's it's hard to do it so fast. It's hard to double every year for 5 years. I mean, like you need to constantly reinvent how the company communicates internally, what processes you use, what structures you use. But we also have to like keep innovating, and it's a competitive market and it's a fast moving market. So I would say that if I had to abstract the highest level, this is kind of the fundamental thing we're going through as a company right now.
Very cool. So I'm going to encourage people to put questions on the Q&A in Zoom. I mean, I'm curious in terms of how you've developed as an entrepreneur. I mean, first of all, I'm curious what surprised you in the journey, and also for people who didn't think you guys were going to make it, the skeptics about the way you were thinking about the company. I'm curious what was it they were skeptical about, and how did you have the confidence to sort of overlook that or work around that?
Yeah. By the way, I got the skeptic part, but I was so thinking about the skeptics. What was the first part of the question?
Yeah, I guess what surprised you on the entrepreneurial journey about your own personal growth as an entrepreneur? Yeah. What's kind of caught you off guard? Yeah, I guess there's sort of two questions, but they're a little related, because I think a piece of this must also be that you end up with a lot of people who are skeptical about the idea.
Yeah, by the way, we were skeptical ourselves. So like, I think that there's some degree of paranoia and doubt that is like necessary to succeed. You need to be like constantly, it's kind of a contradiction. You need to be like really optimistic about the upside, but constantly paranoid about how you're executing towards it.
Yeah, so I tell my grad students the same thing, that you have to fall in love with your work, but be able to be dispassionate about it at the same time. It's challenging. It's a left brain, right brain thing, right?
Yeah, and like, I don't know, those two things are contradictory, but like somehow you have to hold them both in your head.
Exactly.
But I would say that in terms of skepticism, I mean, the number one skepticism always for us was like these kids that are just like some kids out of Berkeley, and then some faculty that have never had a real job. Are they going to really know how to build a company? Like you have to hire sales, you have to manage, you have to build like the right culture. Like that was definitely for at least 5 years of the company, like the constant, like, okay, are you guys going to really figure this out? And by the way, it's not an unfair criticism. Like it was hard to kind of figure all that stuff out. And, a few coin flips go a different way. Maybe we wouldn't have figured it out in time, So I think that that was kind of the number one thing, and maybe a little bit of self-doubt in that regard as well. But I think that that has not been the issue. That was like kind of what the haters would say at the beginning, maybe fairly. And then what the doubt is now, once we're at this scale, is like, okay, it seems there's a real company here, but how are you possibly going to beat, huge company X, where X is, Google or Amazon or Microsoft, which is fair. I mean, that's once you get to a certain stage, the only viable competitors are these massive companies, but they're great companies. That's how they got to be at that stage. So I would say that's kind of the doubters, both now and then. And largely you have to ignore those people. Like it's not helpful to sit around and like think about that. But then in terms of my own experience and reflections, I think for me, the main thing is like how many failures there are on the way to success, and just like getting to the point where I could like really either fuck something up personally really bad, or just have something go really badly in the company. Maybe it wasn't my fault, but it just happened. And like, just wake up the next day and be like, okay, we're going to fix this and move forward. And how like, there's people that show this graph of like, success doesn't look like nice, steady growth. It's like up and down and sideways and backwards. And then somehow you end up in a decent place. So I think for me, I would say the need for resilience is like the thing that I most have walked away with in the last 10 years. Because even the ones that aren't successful are really hard, but the ones that are successful are really hard too, with lots of, dips and difficult spots throughout the journey.
So there are a number of great questions in the Q&A now, and one I think is really great is, where did you, and I guess also the other members of the founding team, learn how to do this, pivoting or in being, there's a strategic aspect to how you guys got the company off the ground, and I'm just curious, how did you and the other members of the team learn how to do that, or did you have some advisors that helped you do that, or was it sort of a collective effort? How did that, the ideation of figuring out the right strategy for the company?
Yeah, there's two things. I think like learning how to find product market fit was actually a little bit easier for us because it's more similar to just like the research problem. And it was actually good, really great researchers, that were my mentors that helped start it. And so that part came a little bit more naturally to us. It's not quite the same as research, but it's the same. You need to have a hypothesis. You need to like figure out if it's true or not. You need to solve a problem that's worth solving. The harder part was like learning how to actually scale and execute in a business, because that's very different than being in grad school. Like that's like, how do you get 1,000 people to move in the same direction? How do you set up your promotion structure, and how do you set up goals, and what culture do you want in the company? And do you want a super cutthroat culture where like you might move faster, but everyone's like at each other's backs? Or do you want a really consensus driven culture, but where everyone's super nice, but things might go really slowly? And obviously those are super oversimplifications, and there's a huge set of things in the middle. So that part, I mean, certainly we read books and like talked to our investors and tried to get as much help as we could. But I think there's kind of no substitute for just doing it and falling on your face and just being able to respond and learn very quickly. I think that's the only way that you really learn.
Very cool. So there's a number of questions around, thinking about academic industry engagement. I'm curious your general thoughts on that now, having obviously spent time at 2 universities as well as at a large company. And how do you think about how industry can engage better with academia, and how academics should think about the work they do if their goal is to have some sort of impact on the practice?
Yeah, like that's a great question. And I think it varies a bit by discipline. I feel pretty confident about discussing like computer science and computer systems area. It might be really different in other areas, but certainly in this area, the good news is that a lot of great companies in this area are built, but either founded by or have amongst their very most important employees, people who did have a PhD. And I've seen that at Databricks as well. Speaking as a PhD dropout, like, a little bit hypocritical, but I've seen that like the depth of critical thinking and problem solving that you learn when you're a PhD student in at least computer science and computer systems, and the need to really be rigorous in your thinking to understand how to respond to challenges to an idea, that actually is very important in, I would say, highly innovative computer science companies or computer science backed companies. And so I definitely would not say, oh, you should, bail on your PhD if you want to do something significant. In fact, there's more people with PhDs that have either started or been really influential in those top companies than probably without. So I do think there's a great degree of synergies between what you study in the research capacity and building a company. Now, the one thing is some people are like, oh, well, I wonder about monetizing my direct research. That's actually much more rare. Like we happen to have done that, but I would say that, 1 out of 100 PhDs who goes and starts or becomes a significant role in a startup isn't actually the thing they were doing. It's more often that the skills and the mindset is the thing that translates. So I sometimes feel like people are overly worried about commercializing their particular research. Sometimes it makes sense, sometimes it doesn't. But I do think it's quite valuable to have that skill set in general.
Yeah, I agree with you. I think the tricky part about commercializing PhD research, I mean, one is sometimes it's too far out, depending on the researcher, just might not be ready for the market yet. And in other cases, even if it could be, you don't have the luxury to pivot. I mean, if you pivot all the time in your PhD, you never finish.
Yeah.
Right. And it could be that to reach the market that you need, you actually do need to pivot, but you can't afford to.
Exactly. So like, yeah. So it's, you want to be careful starting with a hammer and then being like, oh, okay, where's a nail? Like if you start with the problem, and if your research was like that, maybe that it could, because your research already was starting with an important problem, but I would say don't get overly attached to your particular research. By the way, if you look at like the first thing we did, we actually went and built, we went in these companies, we thought, oh, we're amazing like systems researchers. So the way we're going to win is by building super fast, low level compute infrastructure. The first thing we built, we went into all these companies and they're like, look, we don't care that much about price performance and this stuff. We're actually having trouble getting these humans to work together. There's like a data scientist and a machine learning person, and there's like a domain expert in this area, but they don't know anything about data science. And we're just trying to get them to like predict where we should drill for oil and gas, but they're like stuck. So the first thing we built was like UI-based visual tools for doing data science, which was like totally not what our research was in at all. And in fact, we just quickly went and like read about UI engineering and how to do it and how to like use the frameworks. Like we didn't know anything about that. We probably spent the first year of the company almost exclusively doing that, doing almost nothing related to the execution engine and the stuff we did. So even though we were a company that was like based on the research we were doing, within a year of being in the company, we drastically pivoted our focus from the things we had been researching. So it's kind of consistent with like, it's more about how to think than about what the specific thing you're covering is.
So I'm curious, there's a question in the chat about, the initial investors, the very first round and the very early customers. I was wondering if you could say a little bit about, either, specifically about who they were or just what drove them to be the early investors and adopters.
Yeah, so there's investors and adopters, and it's pretty different. So the investors, I think we got a very small amount of money from friends and family at the beginning. And that's more like, hey, I love you, son. Here's a little bit to help you get started. It's kind of based on that. Like, it's not based on their super savvy investors. And, it's just like, okay, these guys need a little bit of help. And the amounts we would raise would be in like the tens of thousands of dollars, maybe from one person. And then a few of those. And it was funny because we started paying ourselves. And I remember as a grad student, I made like $27,000 a year. And then I think we paid ourselves like $40,000 a year at the beginning. And I was like, man, I'm giving myself like too much. This is like too much luxury, this salary I'm giving myself.
And living in San Francisco too.
Yeah, living in San Francisco. I was like, I don't know. We're really like, this is our investors' money. Like, should we be spending this much? Like, so yeah, we were not spending it largely on salaries. A lot of it was like compute costs and stuff. But so at the very beginning, it was kind of friends and family. And then Ben Horowitz was an early investor of ours. And we actually we were not going to raise that much money. We wanted to spend time kind of figuring out product market fit. But he had known a close friend of ours, this guy, Scott Schenker, who well, I think, Jen, in the research capacity. And Scott had started Nicira. That was a really big success for them and for Andreessen Horowitz, who had invested in them. And then Scott called Ben and said, hey, these guys are really good. You should work with them. And he got excited. And then he kind of offered us a great deal, basically, a lot of money and really good, really founder-friendly terms. And we weren't planning to raise money yet at that time, but he just made such a compelling offer. And we were like, okay, well, what else are we waiting for? Why not? So that definitely accelerated things quite a bit. But that was our first kind of investors. And on the customer side, the first users were really people who, honestly, the first people that used the product, it was again, friends and family. It was like, please, hey, my cousin works at a data science company. Maybe I can convince him. And it was just like, hey, can you please just play with this for an hour and tell us what you think? So there's a lot more in it for you than for them when they're your first customers. So it's a lot of, frankly, like begging. And then the tier that came slightly after that were still friends and family, but people that were, I would say, or not family really, but like associates, okay, I know this person personally, worked with them before, but they really kind of bought into the vision. They kind of said, okay, this is where this is going to go. And I do believe this is like the right way to do data science, to build machine learning platforms. And we could kind of convince them on the vision because there wasn't enough there yet to really make it valuable, but they kind of believed in us. And then in return, we would develop with them and we'd really try to make them successful in their jobs and what they were doing. But that was kind of the first set of customers. Yeah.
Yeah, very cool. So, I mean, you guys have been at this for a while, and I'm curious, and also obviously the last 2 years have been hard on everyone, and I imagine on the individuals at the company too. I'm just curious how you think about the energy and work-life balance and general, just keeping people sane when there's just so much to do and so much going on.
Yeah, I mean,
it's a company culture question, also just a personal question to you too. How do you you obviously can't do it all, so how do you How do you make
Yeah,
it feel like you're doing it all?
I mean, yeah, so there's kind of two things. There's like general work-life balance and then the pandemic period and the difficulty that people have had working from
Yeah.
home. I mean, on the general one, I think there's been different stages in the company. I mean, at the earliest stage, you really kind of have to work really hard. And I know people don't, it's not always like popular to say that these days. And by the way, this is not true of every company everywhere, but if you're gonna go and try to start a company, you kind of have to work really hard. And the reason why is like you have so few advantages going for you. You're smaller, you don't know what you're doing, you never built a company before, that one thing you can compensate for those disadvantages is just working 3 times as hard as everyone else in the market you're going after. Because there's so much learning you need to do at the beginning. I would say that at some point, were you gonna say something, Jen, on that? Okay, at some point, it becomes, if you're a very ambitious company, you do keep that hardworking culture, but maybe not to the degree at the very beginning. Because like people have lives, we all, like all of us that founded the company have kids now. We're learning about, this balance that needs to happen, and a lot of our employees do as well. But it becomes more important, like the strategic decisions that you're making. Like which, are you betting on the right long-term trends? Are you on the right side of history? Are you navigating the competitive market well? This becomes more important than just like raw effort, because you can't like raw effort your way to the right strategy. You actually need to be thinking hard about how it goes. So I would say that the taxing parts now are not so much like, oh, I didn't get a lot of sleep because we were working really hard last night. It's more like, I'm sending 1,000 people in some direction. My God, I hope I'm doing the right thing for these people, because like, if it goes well, these people will all have great, awesome careers and make a ton of money. And if it doesn't go well, someday I might have to be in a position of like telling them it's not working and we're laying people off. Like the stakes are high. And so I think a lot of the difficulty comes in just the obligation that I feel, at least to every person that works Databricks, which is to kind of steward it, shepherd it well and send them in the right direction. The pandemic certainly has been really hard for many of us. And what we've seen from our employees is, on the one hand, people actually feel like, oh, I'm actually getting more work done during the day because I don't commute. Like commutes, people hate their commutes. They're really happy to not be commuting. They feel like they actually are spending more time working, feeling that they're more productive. But the bigger picture things of like, am I excited to come to work? Do I understand what I'm doing? Do I like my teammates? Do I see how I fit into the picture? Do I occasionally get to talk to my boss or the boss's boss, or, see the founders? Like that stuff is really missing, the human part. And it's reminding me how much, despite, everything, humans are very socially motivated creatures. We want to be there for our teammates, and we want to laugh and hang out, and like, that's really missing for people. So I think like we are actually one of the companies that's more standing by, like we want to be a site-centric company. We want to have people in the office. We haven't hired a ton of people in totally random locations. We've really tried to keep our company site-oriented, even though right now we're largely not in those sites. So that's been the pattern I've seen so far.
That's really great. I mean, I think we're experiencing similar things at Princeton. I mean, as you know, Princeton's a very residential place, and not being able to break bread together really just diminishes the experience a lot, even though I think a lot of us are happy to have shortened our commutes for sure. So I'm curious, I mean, thinking about Princeton and your time at Princeton, I'm curious, like, what do you feel your undergrad experience gave you that helped you in your journey? And also, what did you learn later where you're like, God, I wish someone had told me this, or I'd had a class in that. I'm just curious, both things you learned and things you wish you'd learned.
Yeah, I think like the thing what resonated from Princeton, I think when I went to Princeton, that was, and I had gone to pretty good schools like growing up, but that was the first time I got to a place and just thought, wow, the average level of talent here is very high. Like these people are just, in all different areas, there's just a lot of driven and impressive people here. And the thing that what can happen when so many great people get together is really special. Like they can do amazing things. And that definitely, when we started Databricks and grew Databricks, we always focused on just trying to find really great people to bring in the company. And that has to be our North Star, like top tier people who work hard, people who are nice to work with, people who are driven, people who believe in the mission. And I think that, that appreciation what it means to work with truly phenomenal people was like something I really was first felt very exposed to at Princeton, both the students and the faculty and mentors I had throughout the way. So I think that, having high standards, sort of really trying to be the best at whatever pursuit you're going for, I think that is something I carried with me. And I saw that in both you and Mike as faculty that I was close with, but also my peers who've gone on to do really awesome things too. So I think like just, I think that kind of really trying to do something important and useful with yourself and being driven, that and trying to be around people like that definitely resonated with me after college. The thing that I didn't learn enough of is this, like, you're going to fall on your face like 100 times on the way up. And in some ways, like, those are maybe two sides of the same coin, because like, at Princeton, even though it's super challenging school, there's still a lot of help. Like when I didn't do well on my math test, you, Jen, were like, hey, Patrick, like, don't worry about it, buddy. I got you. Like, we're going to do fine. So I had like help and people nudging me along the way. And I didn't really spectacularly fail at anything. But then once I left Princeton, I kind of just on that way up, you're just trying to do so many things that you don't know how to do. And we had to be kind of fearless and at the same time, ready to accept our failures. So I think I didn't get enough practice failing at Princeton, or when I did, there was which is great. I mean, it's a good thing. There's a great support network, and I think that's awesome. But when you go into the real world, it's a little different in terms of the support network. Jen, you don't still email me when I have like a bad day at work or I make a bad decision, which is probably healthy for me personally, that I'm on my own. But when I did hit those first few failures, I maybe was too existentially worried when I should have just seen it as like, okay, we're just going to keep going from here.
So this point about, figuring out how to get people comfortable or experience with failure, I've heard this from other people in similar boats from you. And I'm always puzzled how to translate that into action, because I mean, you sort of, I hear people say reward failure, and then you don't know what does that mean? Because obviously there's different kinds of failure. There's failure of not doing the right thing or not trying hard enough or whatever, but you want people to take risk. And I'm curious how in an academic setting, I'm just curious if you have thoughts how to.
Yeah, I mean, it's a difficult question because like, what's the implication? You should want the students to fail more? Like, that doesn't seem right. Like,
yeah, exactly.
So that doesn't seem right. The job of the university is to like help nurture the students and like help them kind of get on their way. And so I don't know, maybe it's just intrinsic. Like when you're in an institution like that, their job is to help everyone succeed, and that's their goal, and that's fine. But I definitely did see, and I see it from students that we hire that come out of schools with less of a support network. Like, I went to Berkeley after Princeton, and it's an amazing school, but they don't have the resources to handhold a lot of the students. Like, it's kind of like sink or swim a little bit. It's not because they're trying to do that. They just have like 1/10 of the resources per student, as a Princeton or a really top tier private school. And so like the students that come out of there are a bit more resilient from what I've seen. And I think, yeah, I don't know. I certainly would never want Princeton to have the attitude that they don't want to help their students. So I don't know if it's a catch-22 and like you just need to pick your poison. But the poison that Princeton picks is maybe we nurture a little too much, but I don't know. I don't have a great
I don't know. Maybe there's some model where it's more like a project-based course where it's going to be pass fail, or we're not trying to grade people on how well they took risk, whether or not they failed, right? Something that doesn't require sort of quantitative evaluation.
Yeah, definitely. And like, I think there was certain pass fail things when I was at Princeton, but it wasn't super common. I think you could take courses pass fail, like one every once in a while. I don't know what it's like now, but yeah, I think like if you can create that environment where there can be like, pretty big risk taking that might fail, that's kind of what I think those students need a little bit more of. But do I know exactly how to do it? No, I don't. I wish I did.
Yeah, I know it's an interesting puzzle. So I'm curious also, I mean, one other thing I find neat about your company is the emphasis on systems. And if you look at the current crop of students, like I think in a lot of places, there's a lot of interest in machine learning, and obviously that animates your business too, but there are all these other pieces. And I'm wondering also, what can a university do better to help people connect the dots? I think people don't always see systems and ML as two peas in a pod. They think of them as sort of either or. I'm going to do ML or I'm going to do systems.
Yeah, I mean, I think a lot of it's derived from the way that the research field evolved. Like there's just, by the way, it's similar to like databases and systems used to be this like totally different areas. And it was funny because all the systems people started solving kind of like database type problems. This was like another like 15 years ago. And then the database people were like, they're not really doing it in the right way. But then they actually kept building all these systems that were pretty influential. And there's still a little bit of like, well, you're not really a database person. Like you're just a systems person who's trying to figure out databases. Like basically Mike Friedman, who's, you know, your colleague, my former advisor, he's kind of a systems guy, but he basically started a database company. Yep. That's what they're doing. So like those worlds are just like, everyone's kind of realizing, okay, wait, this is all the same stuff, really. And I think that needs to happen in sort of the systems and machine learning world. And actually, frankly, I think it's like systems, databases, and machine learning. It's all the same. Like the way, in fact, the way we've articulated our product is this more unified thing of like, these aren't distinct problems. Like you want to deploy a model into production. Well, the quality of the data that model was trained on and the lineage of the data that model was trained on is really important. It's actually as important as like, did you use exactly the optimal formulation of the model? How big is your data and how accurate is data is actually more important in many cases than how fancy the model is. So I think like there's not enough at the intersection of these. I think like one lever schools have is, you know, encourage and hire faculty who are exploring the intersection of these areas, because then, you know, they'll explore it and they'll teach their students about it and like it'll get the flywheel going. But I think it can be very difficult when there's like research communities and conferences and everything that are like in these different areas. They become self-perpetuating. I think a colleague of mine, Peter Bayless, I think helped start, I think a few people helped, but I know Peter's involved, this SysML conference, which is kind of trying to be like, hey, this is somewhere in systems, somewhere in machine learning. And of course, it's all the young people that start this, right? Because like the older generation is like, you know, stuck in their old world. So everyone that started that conference is like, you know, less than 30 at the time or something. So, so I think like it's a little bit just the new generation of researchers need to emphasize this, and hopefully faculty will listen when they're thinking about who they hire and what courses they build and stuff like that.
That's really great. Well, this has really been a fabulous conversation. I think we're going to have to close in a couple of minutes, but I really wanted to ask you one final question about, you know, advice. You know, that you're 11 years out of Princeton now. There's a new generation of students about to graduate, and you know, some that are making choices for what they're going to do the next couple of years that they have left at Princeton. And I'm just curious, you know, with the benefit of hindsight, what would you advise them to do, particularly if they hope to have significant real world impact like you and your colleagues have done?
Yeah, I mean, I think like weirdly, my advice is like, don't be overly prescriptive or planning about the next 10 years of your life. It's really hard to know what thing is going to lead to what other thing, which is going to lead to an opportunity, which is like, I thought I was going to do a PhD and then I ended up founding this massive company. Now the things I do are about like building teams and hiring. It's like kind of totally nothing like what a PhD is like. So I just encourage people, like, especially when I see young people today, they're trying to make a 10-year plan, but they have like the signal to noise ratio on that plan is not good. Like you can't look 10 years out. Don't even bother. Like think about what you enjoy, what you love. And honestly, the one thing that's invariant in my career is just trying to find great people to work with. Like find the people that work with you that they're barely willing to work with you because they're so much better than you. And you like have to elbow your way in for them to even like talk to you. I mean, when I went to Berkeley with those guys, I was like 7 years younger than all of them. I was like the young kid and they barely were like willing to talk to me. And I think like, if you get in, you know, there's the saying, like, I would never want to be a member of a club that would have me as a member, kind of like that. Like find great people that you can learn from and work with. Don't worry too much about, you know, what the next 10 years looks like. Just worry about what the next year or two looks like. And that would be my main advice to people.
Wonderful. Thanks so much, Patrick. And I really appreciate your making the time. I know it's a busy time for all of us, and especially for people that are running a company. So thanks so much for making the time. Really appreciate it.
Thanks, Jen. And thanks everyone who's here now or watching this later. Appreciate it.
Awesome. Have a lovely rest of your day.